In this video, we're going to graph quadratics. That means your quadratic is going to be given in either standard form, vertex form, or intercept form, which is also known as factored form. Let's get started with the first instructions. If you're given your quadratic in standard form, here are 4 suggested steps in order for you to graph this quadratic. The first thing you want to do is to calculate the vertex. Then you want to create a table of values to find 2 points that are lower or higher from the vertex. Lower and higher in terms of the x value of the vertex. Above and below is a reference in the actual table. Then you're going to find all the y coordinates of those 5 points, and you're going to plot the points and graph. In order to calculate for the vertex, you're calculating for the x coordinate of vertex. You're going to use this formula. -1/2 times b over a. The most popular one that you're going to be told to use is -b over 2a. It's a modification of this formula. The reason I like using the formula on the left is because it is a little bit less confusing in terms of where the negative sign goes, as well as for students to not forget the sign for b and a. In this first example, we are asked to graph the equation y equals -2x squared minus 16x minus 35. And the first thing we want to do is find the x coordinate of the vertex. So -1/2 times b over a. Here's my a, b, and c numbers. Again, a, b, and c are just numbers, no variables. So -1/2 times b is -16, a is -2. This becomes +16 over -4, which reduces to -4. Because I want 2 points that are lower than -4 and 2 that are higher than -4, I'm going to place -4 here. 2 numbers that are lower than -4 are -5 and -6. And then 2 other numbers that are greater than -4 are -3 and -2. So now that I find those x numbers, I need to find the y's to complete the table. So when x equals -6, I have -2 times -6 squared minus 16 times -6 minus 35. That means it's -2 times 36 plus 96 minus 35. When you do this all in the calculator, y is equal to -11. Now to figure out use a different way of notating this. Y, when x equals -5, that equals to -2 times -5 squared minus 16 times -5 minus 35. So that's -2 times 25 plus 80 minus 35. Again, when we do this in the calculator, this is equal to -5. let's see what we get when x equals -4. That is equal to -2 times -4 squared minus 16 times -4 minus 35. So that itself is -2 times positive 16 plus 64 minus 35. Once you input that into the calculator, that is equal to -3. Alright, let's finish the table off in the next slide. What is y equal to when x is -3? It's -2 times -3 squared minus 16 times -3 minus 35. And that's -2 times positive 9 plus 48 minus 35. When you do that in the calculator, that is equal to -5. What is y when x is equal to -2? -2 times -2 squared minus 16 times -2 minus 35. That is -2 times 4 plus 32 minus 35. Again, use a calculator, so when x equals -2, that is equal to -11. Now, as you can see, alright, this is our vertex. Numbers lower and higher on the x value of the vertex, but the y representation is mirrored the same distance from the vertex. And these are the points we are going to plot in our graph or our coordinate plane. So here's our table again. All we have to do is just plot the points and then almost connect the dots. Make it look like a parabola as opposed to straight curve. So -6 on the x and -11 on the y. -5 and -5. -4, -3. -3, -5. And -2, -11. Alright, remember, parabola looks like a U. So this is where we got kind of a U right already. So, again, not connecting the dots. Right, because from here to the next point, it's going to be much faster. And there is our parabola. Next, we're going to graph our parabola, or I should say our quadratic, in vertex form. Similar steps, we are going to calculate to find the vertex, create a table of values to find 2 points that are lower or higher from the vertex, meaning above or below the x part on the actual table. We're going to calculate to find all y coordinates, and then we're going to plot the points to make the graph of the parabola. Right, so we're given the equation y equals 3 times the quantity of x plus 2 squared minus 2. There is a line in the movie The Godfather Part 2 that I like to use. This line helps students identify the vertex when we're given an equation in this specific form. That line is the following: keep your friends close, but your enemies closer. Right, if you are very cool with someone, right, you're going to follow that friend's advice. But if you have an enemy, you're not going to follow the advice. Tendencies are you're going to do the complete opposite of that. And this is where the finding the vertex comes into play. All right. Pretend this is you. All right. So in this case, if you're keeping your enemies closer to you than your friends, this is your enemy. And then this over here at last is going to be your friend. So that means, right, that if you're going to do the complete opposite of what your enemy is telling you to do, right, if this is positive 2, you're going to do negative 2. And if your friend tells you to do negative 2 things, you are still going to do those negative 2 things. So this here is the coordinates of your vertex. This is your friend advising you to take negative 2 steps. You're going to take negative 2 steps or 2 steps back. If your enemy tells you to take 2 steps forward, right, because in the end you don't trust your enemy, you're taking 2 steps back. So again, the first one, or the one inside the parentheses, always is going to belong to the x coordinate. At the very end, this is going to be our y coordinate. So in this case, this is going to be negative 2, negative 2. So now we got to find these other points to complete the table. So now that negative 2, right, numbers that are lower in the number line and higher in the number line, and substitute in here to figure out these y values. What is y equal when x is negative 4? 3 times negative 4 plus 2, raise that squared, minus 2. Again, do everything inside the parentheses first. Apply the exponents first before you multiply with the 3. 3 times 4, that's 12, minus 2, that is 10. So y, when x is negative 4, y is equal to positive 10. What is y when x equals negative 3? This is the correct work. When you do that in the calculator, you are going to get that is equal to 1. Let's find out what the y result is when x is negative 1 and x is 0 on their own respective sides. We should get that y is equal to 1 when x is negative 1, and when x is 0, y should be positive 10 because it's properties of a parabola. But let's verify for sure. When x is equal to negative 1, that's 3 times negative 1 plus 2 squared minus 2. 3 times negative 1 squared minus 2, and that indeed is 1. This is going to be positive 1 when we squared. 3 times positive 1 is 3, minus 2 is 1. What's the y result when x is equal to 0? 0 plus 2 is 2. Squared, that is 4. 3 times 4 is 12, minus 2 is equal to 10. So as we see, they do match each other's, and now we got to do is just graph. We had negative 4, 10, negative 3, 1, -2, -2, -1, 1, and 0, 10. Alright, we can see the parabola started taking the shape of a U. One thing that I forgot to do in the first example is actually do this. Not erase it. I forgot to label this graph. Label it with the equation that I just graphed. And there's our parabola. What if our equation is in standard form? What we're going to do is we're going to calculate for the x-intercepts, calculate for the vertex by taking the average of the two x-intercepts. Since this is a quadratic, there's only at most two x-intercepts. We're going to create a table of values for the x-intercepts, vertex, and 1 point higher or lower, literally in the table of values, than the x-intercept. Calculate for all y values, and then plot the graph of 4 points. And I'll get to in a bit what I mean by 4 points. Let's get started then. Alright, so this is going to come very similar fun when we solved by factoring. In order to do that, we're going to set each factor, this is a factor, this is a factor, and that's a factor, equal to 0. Since we are looking for x-intercepts, which are also zeros, roots, or solutions. Alright, we're going to set the two factors that have a variable, because if I set this equal to 0, I am going to get a statement that does not make sense. 2 equals 0 is not a true statement. So x plus 3 equals to 0. X minus 1 is equal to 0. This is going to help create our x-intercepts, in this case plural because we have two different solutions. So -3, +1. That's the first thing we want to do. Check. Calculate the vertex by taking the average of the two x-intercepts. So I'm going to add these two values and then divide by 2, since I'm only adding 2, and that is their average. So -3 plus 1, and then divide that by 2. That's -2, divide that by 2, -1. So -1 is the average, and that is the vertex. So that's checked off. Create a table of values for the x-intercepts. Use the x-intercepts, vertex, and 1 point higher and lower than x-intercepts. So any point over here. What's the next point after -3? Let's just go -4. The next value after 1 is +2. Before I start substituting numbers to find these y values, we know that this is going to be 0, and this is going to be 0 because these are x-intercepts. Recall, an x-intercept is the location where the y value is 0, so these are going to be zeros. So the only work we need to do is for -4, -1, and +2. So let's find those numbers. What is y when x equals -4? 2 times -4 plus 3 times -4 minus 1. -4 plus 3 is -1. -4 minus 1 is -5. So y is equal to, when x is -4, 2 times -1 is -2, times -5 is +10. What is the y value when x is -1. Alright, you try that out. I'm going to give you a couple of seconds before you try that out. Just go ahead and pause. Alright, now that you find that out, 2 times -1, messed up already, times -1 plus 3 times -1 minus 1. That's 2 times 2 times -2. That is equal to -8. Again, figure out what the y value when x is -2. I'll give you some time. Go ahead and pause this video. Then I'm going to continue finding the y value. Alright, now that you hopefully found it, here's the verified work. 2 times 2 plus 3 times 2 minus 1. 2 plus 3 is 5. 2 minus 1 is 1. 2 times 5 is 10, times 1 is still 10. So here's my table of values. Let's plot these points. I don't know why I said 4 points, but plotting these 5, it makes it much better to see the parabola. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so -2, -4, -6, -8, -10. -2, -4, 6, -8, -10. Right, it's important that we label and show our increments for our coordinate plane. So -4, 10 is right here. -3, 0. -1, -8, 1, 0, 2, 10. If you wanted to, you could have found the value when x is 0, when x is -2. That's fine. It helps you be more accurate. But here is the parabola. It's all nice and floppy, but here it is. Hopefully this video, those 3 different methods, helped you understand how to graph your parabolas.